my friends, welcome back. Now let's see what a thread library is all about. It's a collection of functions that provides an API to create and manage threads in the user space. In the user space, the user needs some support to create a thread, work with the thread, manage the threads, because the user may not be having appropriate knowledge to create all these things, so needs some support. But the same in the kernel space, the kernel side is created by experts, and hence we don't require any APIs too. So for the user we do require APIs. So these APIs provide the facilities to create and manage the threads in the user space. So the library helps in developing, for creating, managing, synchronizing the threads and controlling the schedule behavior of the threads. It's abstract away the operating system specific implementation details, so the user don't have to know all the details about the implementation. So the whole system is put under abstract, and only what is important for the user, only that is made visible to the user, so that user can work with minimum efforts, minimum knowledge, can do it. So some of the functions provided by the thread libraries. So to create a new thread, we have a create function. To terminate the current thread, we have an exit function. To make a thread wait to finish is a join function. And to voluntarily give up the CPU. So if a thread is already scheduled and it is working and is using a CPU, and we realize that currently thread cannot continue using the CPU for some reasons, then we can just voluntarily give up the CPU. Then we have a mutual exclusive lock, that's a lock a resource. That means when one process is trying to use a resource, then we must ensure that other processes do not use it. So we should put a lock before using any resource, and that lock is mutual exclusive lock. So we can lock the resource before using it, and after usage is done, so we can unlock and allow others to use that resource, and so on. So these are the various functions available. Then we have something called pthread, which is the POSIX threads. It's a standard API for multi-threading in C or C++, which is supported by most Unix and Linux systems. So this allows creating and managing the threads, allows synchronizing threads using mutex and conditional variables. And the various pthread functions, we can see that you can pthread create, pthread exit, pthread join, pthread mutex lock, pthread mutex unlock, and conditional wait and signal. So let's check with an example. So here what is it trying to do is we have creating a thread named hello thread, which simply prints a hello from the thread, and once the printing is done, it just returns back, nothing is returned. Then in the main program we are creating one ID for the thread. A thread ID is created, which we call TID, and then we create a thread with that ID, and name of the thread we call it hello thread, which is one function we have already defined. So this function is attached to this thread, and then we say join. Join means the parent thread should wait till this thread TID is running. So wait for the thread to finish, and once the thread finishes its action, then it just comes out and the parent thread will print that thread has finished and then return 0. So in all, what is it doing is, we created a thread like a child process. Its name is hello thread, and that's written here, and then we wait for that thread to complete its action. So the moment it is created, it goes there and starts working, and as long as this is working, the parent process will keep waiting. So that's the join, and once this process is done, then it prints finish and come out. So let's just look at the running of this one. So here the same program we have. If I just run it, it says hello from the thread, and then the thread is finished. So we can run it again. So hello from the thread. So the thread is created, hello thread, and in the hello thread it says hello from the thread. So we can say modify this. Hi friends, let's look at another example of multi-threading. Here we have code that has got two threads, and these two threads were created, and then the two threads use this function to print the numbers, and this print number keeps printing from 0 to 4, and this is used by each of these two threads. And when we run this, so first thing is we create two threads and we make both the threads join. That means the main thread which created these two threads will wait till both of the threads do their execution, and once it is done, then this will also close it. So if we run this, then what we have is this code which makes two threads. So this we are making two threads, two threads, and if we run this, then it says thread 2 started working, because the operating system gave chance for thread 2 to start. So thread 2 went into execution, then it started printing 0 1 2 3 4. After thread 2 completed, then thread 1 gets the chance, then it prints 0 1 2 3 4. If I run this again, then in this case thread 1 comes first, then 0 1 2 3 4 is printed, then thread 2 starts its work 0 1 2 3 4. If I make it another time, then again it happens other way. Now instead of two threads, if I make it three threads, then the whole situation now will work for 3 threads. And if I run this, yeah, thread 1, then thread 2, then thread 3, and if I run this again, then thread 1, thread 2, thread 3 only in the same order we are getting. Now here thread 2 0 1 printed, then timeout, then thread 3 gets a chance 0 1 2 3 printed. Before thread 3 could print 4, thread 2 came back and it printed the remaining 2 3 4, and then thread 1 was given chance 0 1 2 3 4 was printed, and for thread 3 somewhere in between 4 was also printed. So this is how the scheduling between the threads takes place, and this example very clearly explains. So that's it for now. Thank you.